Assalamu alaikum. My name is Arina Ali. Today the topic of my presentation is polyurethane manufacturing. Polyurethane is a versatile polymer used in various applications. This presentation covers its manufacturing process, details, chemical reaction mechanism, and technical engineering aspects. Overview of polyurethane. Definition and uses. Polyurethane is a polymer composed of organic units joined by carbamide links. Types of polyurethane. Many types include flexible foams, rigid foams, coatings, adhesives, and elastomers. Market demand. The polyurethane market is growing due to demand for energy efficient materials. Chemical structure and properties. Chemical composition. Polyurethane is synthesized from isocyanides and polyols. The ratio and type of these components determine the final properties. Reaction mechanism. The polymerization process involves the reaction of isocyanates groups with hydroxyl groups to form urethane linkage. Thermal and mechanical properties. Polyurethanes exhibit excellent stability, resistance, and strength for various applications. Manufacturing processes. Polymerization techniques. Common techniques include bulk polymerization, solution polymerization, and dispersion polymerization, each influencing the characteristics of the final product. Foaming process. The production of polyurethane foams involves a reaction between isocyanates and polyols, often with the addition of blowing agents to create a cellular structure. Casting and molding. Liquid polyurethane can be poured into molds to create specific shapes, allowing for detailed designs in products like automotive parts and industrial components. Detailed chemical reaction mechanism. This present outlines a comprehensive overview of the chemical reaction mechanism. Detail respects role of catalysts and additives and the importance of controlling reaction conditions to adhesive desired polymer properties. Step-by-step reaction. Formation of urethane linkage chain extension and cross-linking. Catalysts and additives. Amines and tin compounds accelerate reactions. Additives improve properties. Control of reaction conditions, temperature, pressure, and humidity affect polymer properties. Application of polyurethane. Construction and insulation. Rigid polyurethane forms are widely used for insulation in buildings, offering excellent thermal resistance and energy efficiency. Automotive industry. Polyurethane is used in automotive setting, dashboards, and insulation materials, contributing to lightweight design and improved comfort. Consumer products. From mattress to sporting good, flexible polyurethane foams provide comfort and durability, enhancing the user experience in various products. Environmental considerations, sustainability challenges. The production of polyurethanes can involve hazardous chemicals, raising concern about environmental impact and worker safety. Recycling and use. Efforts are being made to develop methods for recycling polyurethane products, such as chemical recycling processes that break down the polymer into reusable monomers. Emerging bio-based alternatives. Research is focused on developing bio-based polyols from renewable sources, aiming to reduce the carbon footprint of polyurethane production. Technical engineering aspects. Process optimization. Engineers continuously seek to optimize manufacturing process for efficiency, cost, effectiveness, and sustainability, employing techniques like lean manufacturing. Quality control measures. Rigorous testing and quality control are essential in polyurethane production to ensure consistent material properties and compliance with industry standards. Innovative formulation. Development of new formulation tailored for specific applications such as flame resistant or high performance polyurethanes is a key area of engineering research. Future trends in polyurethane. Advancement in technology innovation is processing technologies such as 3D printing with polyurethanes are expanding the possibilities for product design and customization. Smart materials, the integration of sensors and smart technology into polyurethane product is emerging, enabling responsive application in various industries. Market growth projects. The polyurethane market is expected to continue growing, driven by demand in emerging markets and advancement in material sciences. Polyurethane essential material insight. Polyurethane unique properties and versatility make it an essential material in various industries. Understanding its manufacturing chemical process, addressing environmental challenges, and enhancing performance characters. Unique properties. Polyurethane exhibits exceptional resilience and durability. Manufacturing process. Understanding the production techniques enhances its application. Sustainability challenges. Research is the key of addressing environmental impacts. This is all about the presentation.